We have a Pi Day every year on March 14th, but a total lunar eclipse on Pi Day? Now that's special. Because pi itself is defined as the ratio of the circumference to the diameter of any circle, and what's more math poetic than two giant circles interacting in our night sky? Let's compute how big is the shadow of the Earth, how big is the circle that we're going to see overshadowing the moon. If that's the moon in our night sky tonight, then there's going to be a shadow that is being cast by Earth at the plane where the moon is, and we want to compute how big that shadow is. That shadow is called the umbra, and we're going to compute how big that is and how big is it in area compared to that of the moon. If the sun is here and then the light is coming towards Earth and the Earth is this wide in diameter, then behind the Earth there will be a shadow, and right where the moon is, if this is the diameter of the moon, this is the diameter of the umbra, and that is what I want to compute to see how big is it compared to the moon itself. By the way, this diagram is wildly out of scale, but it just helps to get an idea of what's going on. If instead of looking at diameters, I look at radii, then this is the radius of the sun. This will be the radius of the Earth. This is the radius of the umbra. That's the one I want to compute. I also know the distance from the moon to the Earth and the distance from the Earth to the sun. So knowing those four constants, I can compute the radius of the umbra. How? Because this triangle over here and this triangle over here are similar triangles, and therefore the length of this side divided by this side has to be the same as the length of this side divided by that side, and that's going to allow me to compute r sub u. Because I get this equality and I can solve for r sub u in terms of the other constants. Now, the distance from the Earth to the sun changes during the year as the Earth travels around the sun, but right now we are at that distance in kilometers. Similarly, the Earth and the moon are not always at the same distance, and right now we are at that many kilometers away. So that gives me the value of dm and ds in thousands of kilometers. Similarly, the radius of the sun, the Earth, and the moon are given by these quantities in thousands of kilometers. These do not change with respect to time. And if I plug in all these quantities into my formula, I get that the radius of the umbra will be about 4,500 kilometers. The radius of the moon is about 1,700 kilometers. And that means that the radius of the umbra will be about 2.6 times the radius of the moon. And finally, to compare the areas of the umbra and the moon, we can use our formulas of the areas to see that the umbra will be about 6.7 times larger than the moon.